So let us start the next topic, that is function. Let us first of all understand what happens in a function. Let us take this little box with an input pipe and output pipe. So when I'm putting something inside it, I will get something out of it. Now what I get out of it depends on what is happening inside. Let us say there is an operator that is happening inside. The operation that is happening inside is whatever I put inside, it is getting multiplied with 2. Okay. So if I put inside, let us say 1, what do I get outside? I'll get 2. If I put 2, I'll get 4. I put 3, I'll get 6. So I am getting the double of whatever I am putting inside it, right? So if I collect all these pairs and write them as my ordered pairs, 1, 2, 2, 4, 3, 6, and let us say this is one of the sets and this is another set. We said that this is a relation, right? And what is the relation between x and y elements? That y is equal to twice of x. This is how we wrote the relations, right? Now a function is also a relation, but a special kind of relation where some of the things need to be taken care of. Number one, what kind of relation is this? It is a special kind of relation where every element, let us say we are talking about relation from A to B. Okay, this is a relation from A to B, and when will it be a function from A to B? This is what we are talking about. Function is a relation, right? It should follow some properties, then this relation will be called a function, otherwise it will be not a function. So when is it a function? When every element of set A, when I am saying this set, that means I am talking about every element of it. No element should be left, right? Every element of set A should have a unique image in set B, right? So the two things that I want to highlight here is that every element of set A and a unique image in set B. These are the two things that I want to highlight here. What I mean is, for example, let us say I've got these two sets A and B, okay, and I've got these elements, and let us say I've got these elements in set B. One is, let us say, related with A, 2 is related with B, 3 is related with C, right? And let us say 4 is not related with any of these elements. Is this a function? Now this is a relation, right? This is very well a relation, because we know that a relation is subset of the Cartesian product of these two sets A and B. But is it a function? No, because this element here does not have an image in this set, right? So this relation is not a function. Keep listening to this lecture, you will understand in 5 minutes what is a function and what is not a function. So let us take any other relation in these sets P to Q. Okay, so 1, 2, 3, 4, A, B, C, D. Let us say these are the elements. Now this 1 is related with A, 1 is, let us say, is related with B also, 2 is related with C, 3 is related with D, and 4 is related with D. Okay. Now this is also a relation, right? If I want to write this relation, what will be this relation? This will be 1 comma A, 1 comma B, 2 comma C, 3 comma D, and then there will be 4 related to D. Now this is perfectly a relation. Now is it a function? No, because I said that every element of this set here should have an image. Now does every element have an image? Yes, all of these have some image in the other set, but then I said it should have a unique image. And if you look at this element here, 1, it has got two images, A and B, right? Element 3 has got a unique image, that is D. Element 4 has got a unique image, that is D. But element 1 has got two images. And if you look here also, this ordered pair and this ordered pair, they have got 1 as their first entry, right? Two ordered pairs have got 1 as their first entry. That means 1 has got two images, more than one images. So it doesn't have a unique image, right? So this is not a function. This is not a function. Now let us consider this scenario where these two sets are there, X and Y, and these are the elements, right? 1 is related with A, 2 is related with B, 3 is related with C, 4 is, let us say, related with D, and you may have, okay, let us consider this scenario first. So is this a function? Yes, it is a function. So this relation is a function. Why? Because every element of this set has a unique image in this set. So every element has got an image, yes, and it has got a unique image, yes. And how do we find that it has got a unique image? Because it is being related to only one element in this set, right? If I write this relation, I'll write it as 1A, 2 is related with B, 3C, 4D. So if you see, in all these ordered pairs, the first element is not being repeated, right? First element 1, 2, 3, 4. When the first element is being repeated, that means this element has got more than one images. So that was not a function. But in this case, the first element is not being repeated, so it is very well a function, right? And all these first elements are from this set. That means this set has got these elements, and all of these elements are there in these ordered pairs. So no element of this set is left, right? So I hope you have understood a little bit about what is a function and what is not. But when I say that there should be nothing that is left in this set, but if something is left in this set, let us say this is again x to y, 4 is, let us say, related with D. Okay, now this is also a function. This E doesn't have a pre-image, right? These have got images. We call these A, B, C and D images of 1, 2, 3 and 4, right? So what is 1 called? 1 is called pre-image of A. A is image of 1 under this function, under the function x to y, right? X to y. But 1 has also got a special name. 1 is called pre-image of A under this function. Okay, so I hope you have understood some of the things. Let us extend this discussion a little bit and think about this box once again. Okay, let us say I draw this box once again. So when I put something inside, some operation is happening and some output is being given, right? Now I should be sure about the output, right? This will be a function. When I am sure about the output, when I am putting 1 inside, that I am getting 2. And if in some circumstance you find a relation that when I am putting 1 inside, I am getting 2 or 3, let us say. These kind of operations are not functions. You should have a unique output. When you're putting something inside, you should have a unique output. Only then it is a function. So let us say you are putting, for example, let us say you are putting 3 inside and you are getting 4 as your output, and if you are, let us say, putting 6 inside, you are getting 4 as your output. It is very well okay, because, and it is a function, because you know when you put 3 inside you will get 4. End of discussion. You know your input, and when you put this inside you get 4, right? You are not confused. When you put 6 inside you are getting 4 perfectly well, because this happens in some of the cases, right? When you are, let us say, putting 2 inside you get 4. Okay, when you are putting, let us say, -2 inside you get 4. So it may happen, right? Then this is very well a function, because you know when you are putting 2 you will get 4. What I mean is, you should not be confused about the output. Let me show it once again through this diagram. 1 2 3 4, A B C D. When you are putting 1 inside, let us say you are getting A, 2 you are getting B, 3 you are getting C, 4 you are getting D. You are not confused. You know what, when you put 1 inside you will get A outside. Okay, but consider this second scenario. Consider this scenario: 1 2 3 A B C. When you are putting 1 you are getting A, or let us say you are getting B, 2 you are getting C, 3 you are getting C. Now there is no problem with these elements. When you are putting 2 you are getting C, you know that. When you are putting 3 you are getting C, it is okay. But see, look at this one. When you are putting 1 inside as your input, you may get A or B, right? So you are not sure about the output. This kind of relations are not functions. Okay, and this relation is a function. Now let us define some of the things. So let me write the formal definition first. Okay, then we will proceed to discuss some other things about functions. A relation from set A to set B is called a function if every element of set A has one and only one, has a unique image in set B. When I say unique, I mean one image and only one image, right? So a relation is from set A to B is called a function from set A to B, right? We denote it like this: f, then such that A to B. So a relation from set A to B is called a function from A to B if every element of set A has a unique image, or one and only one image, in set B. So every element should have an image and it should be a unique image. Alright. Now based on what we put inside and what we get outside, we can define some of the functions. Okay. Let me draw it once again. Let us say the operation that is happening inside, I denote it by f, okay, and what I'm putting inside, let us denote it by x. What I'm getting outside is f of x. Okay, so if, let us say, the function, what I'm getting outside, or the operation that is happening inside it, is 2x. So what is happening inside is, I am putting x inside and it is being multiplied with 2. So I'll get 2x outside. So we can name it by y also. This is my independent variable. So I am putting something inside and this output depends on what I am putting inside. So accordingly output will be given. So this is my dependent variable, this is my independent variable, right? Now if I ask you, what are the values what are the values that you are allowed to put, right? Or what are the allowed input values? So you will say, in place of this x, I can put any real number, any real number. Why? Because at any real number, it will be defined very well, right? I put any real number, it will give me double of that real number outside. Okay, so what all values can you get outside? You can get any real value outside. Now, if I say that there is another box, and the operation that is happening inside is I am getting the reciprocal of what I am putting. So if I put, let us say I am putting 2 inside, what I am getting outside is 1 by 2, right? When I am putting, let us say 3 inside, I am getting 1 by 3. When I am putting 1 by 3 inside, I am getting 3. When I am putting 0 inside, what will I get? 1 by 0, which is not defined, right? So I cannot put such values as my input for which the function itself is not defined, right? So this is not allowed as my input value, not allowed, because the function is not defined at these values. So when I ask you what are the allowed input values for this function, you will say you can put all real numbers in place of this x, and you will get a certain f of x apart from 0. You cannot put 0 in place of x, right? And if I ask you what are the outputs that you get all real values as your outputs except 0, because you cannot get a 0 by putting any real value in place of this x, right? F of x will never be 0, right, when it is equal to 1 by x. So what are the output values that you are getting? Every real number you may get except 0. So what are the input values? Every real number you can put in place of x, but not 0, right? So what are the allowed values of input? This is known as domain of the function, domain of the function. And what are these output values in when you are putting something which is in domain of the function? These are the range of a function. Let me take any other operator or any other function and explain it to you. Let us say what is happening inside is, if I put x, it will give me 1 by x minus 2. Okay, so tell me, if I am putting 3 inside, what do I get? I'll get 1 by 3 minus 2, that is 1 by 1, so I'll get 1. When I am putting 4, I'll get 1 by 4 minus 2, that is 1 by 2. Okay, but when I am putting 2 inside, what will I get? When I put 2, the denominator will become 0, which is not defined. So at 2, this function is not defined. So 2 will not be in my domain, because this is not an allowed input value, so it will not be in the domain. So what is the domain of this function? Domain of this function is all real x you can place, right? All real values except 2. So this is how we look for domain. Finding range is an entirely different topic, but for this you can very well say that 2 is not in the domain of this function. What is the function? 1 by x minus 2. And depending on what you put inside and what you get outside, let us say your output values are real, right? What you are getting out as your output. Okay, if your output is real, okay, it has got real values. Either it has got all real values or entire real numbers or some subset of real values. So if your output is real, then we will call it a real valued, because all the values that we are getting are real valued function. Okay, and if, okay, this is real valued function. Now there can be another function where output is real and input is also real. What I mean is, what you put inside is real number or a subset of real numbers. What you get outside is a real number or subset of real numbers. Then this function is a real function, right? This was real valued function. This is a real function. Okay. I would like to discuss some more things using this box. Then we will proceed to the examples. Let us say if the function that I have is equal to x. So what I mean is, I am putting x inside and I am getting x outside. So what will happen if I put 1 inside? I will get 1 outside. 2 inside, 2 outside. 3 inside, 3 outside. 0, 0. So what is happening is, what I am putting inside, I am getting exactly identical value outside. So this function is also known as identity function. Okay. So what all values of x can I put inside? All real values, right? At every real value this is defined, and what I am getting outside, exactly the same thing. So the range is also a set of real numbers. So domain is a set of real numbers, range is also a set of real numbers. And if you notice, we call this output f of x equal to y, which was dependent variable, and input as x. So if I draw it on the coordinate axis, these will be my coordinates 1 1, right? Every ordered pair here is my coordinate in Cartesian coordinate system. So if I try to draw the graph of identity function, which we will have to do in this chapter. So see, I am trying to draw the graph of this. So I'll take these coordinate axes and draw these coordinates, find these coordinates. So 1 1, 2 2, right? 0 0 is my origin. So if you put something negative, let us say -1 here, you will get -1, because f of x is nothing but equal to x. So -1 will give you -1. And if you join these, you will get this straight line as your graph of identity function. We will discuss more about these graphs in a short while. But one more thing that I would like to say here is that this was one of my graphs. Okay, so how to look at the graphs? This is another thing that I would like to highlight. Then we will proceed to questions. For example, let us say I've got okay, let us talk about the graph that we have just made. This was the graph, right? So what it means is, this graph extends further with no limits. Okay, so it will keep going further in this direction as well as in this direction, until and unless I give you some sign that this graph stops here. For example, if I draw this graph here, and let us say I draw this little circle here, and there is another circle that is a filled circle here. Okay, now this graph has a meaning that this is the only graph that is there, but this graph extends towards right as well as left till infinity. Okay, as we can see, this is graph of f of x equal to x, and we already said that input can be any real value, right? So input can be -infinity to infinity. And what will be the output? Output can also be any real value, so it can be -infinity to infinity. Where do we see the input? This on x-axis, because this f of x is also known as dependent variable. This depends on values of input. So input, I am looking at x-axis. So when I put this value of x, let us say 3, what do I get? I go on this graph and look at the y-axis. This is the value that I will be getting. So of course, this for this graph I am getting 3. So as I told you, 3 3 is my coordinate. So for looking the values of, or looking the domain or the input values, I look at the x-axis. For looking the range, or for finding the range, I look at y-axis. For example, if I look at this input value 2, I'll go to the graph and then look at the y-axis. So I'll get this value. Okay. So, or in terms of f of x, let me write value of 5. So if this is 5, what will be this value? This will be f of 5, which is nothing but 5 here, right? So for any graph, if you want to see its value, right, against any input value, for example, for this value, let us say this is a, so the output will be there at the y-axis, which is f of a. Okay. And what will be the domain? Domain will be every acceptable value of x. For example, for this graph, let us say this is a and this is b. So the domain here for this graph will be a is included, b is not. So this is the domain, right? If this is a graph of this function f, then this is the domain that I have written. What is the range? Range will be like this. I look at the y-axis. This is f of a and this is f of b. So the range of this function, according to this graph, it will be equal to f of a, f of b. Now f of b is not included, right? Okay, because we do not get any value at this b. There is this open circle. This open circle means just that we are not getting any value here. Okay, so I think this is enough introduction to understand this chapter, and let us proceed to some questions now.